This is Algebra 1, and we're going to do a lesson on probability. So first of all, what is probability? Probability indicates the chance that an event will happen. And your probability can be anywhere from 0 to 1. 0 meaning there's no chance that that's going to happen, and 1 is 100% sure that that's going to happen. And then halfway in between would be 1 out of a 2 probability, which means there's a 50% equally likely that the event is going to happen. We're going to do a couple examples. It'll make more sense then. And the way you calculate a probability is the top is the ways that that can happen. Those are favorable outcomes on the top. And the bottom are total possible outcomes, so total ways it can happen. So favorable over total. And the way you write probability is a P, an open parenthesis, your favorable outcome, and then a closed parenthesis, and you read this P of A. Okay, so the first we're going to talk about what's a probability that you'll flip a coin and get a heads. So again, the top is favorable, the bottom is total outcomes. So favorable means we're hoping to land on heads. So our favorable, there's one of those. And total possible outcomes was either heads or tails, so there's 2 outcomes. So that was an example of that 50-50 one. It's a 1 out of 2 probability. You roll a die and get a 6. If you roll a standard die, there's 6 sides, 6 different numbers, 1 to 6. Favorable is 6. We're hoping it lands on a 6. So there's 1 6 on our die and a total of 6 numbers. You choose a card at random from a standard deck of cards and get a 3. If you remember, a deck of cards has 52 cards and it has 4 of each number. So we have 4 3s in our deck of cards. So we're going to go ahead and reduce that 4 over 52. It looks like they probably would reduce that to 1 over 13. So there's a 1 out of 13 chances that we'll get a 3. You have 3 Jolly Ranchers, 2 cherry Jolly Ranchers, 2 grape, and 1 watermelon in your pocket. You randomly stick your hand in and grab one. What's the probability you're going to get a grape? So how many grape do we have? We have 2 grapes in our pocket, and we have a total of, it looks like 6 candies in our pocket. So again, we can reduce that to 1 over 3. And that's the probability of getting a grape, is how you would write that like that. Okay. All right, let's add on something. Okay, we've been talking about events. An event is the set of possible outcomes resulting from a particular experiment. You flip that coin, that's your event. You roll a die, that's your event. You draw a card from a deck of cards. If they're independent events, that means it's not affected by the previous event. In other words, if you flip a coin and you do it twice, it doesn't matter what your first outcome is. Your second experiment is going to be independent of that. The same thing if you roll 2 dice. It doesn't matter what the first one lands on, the second one still is unaffected by the first roll of the die. Okay, so let's try a couple independent experiments. You roll 2 dice and you get 2 4s. Oops, I think I forgot something. There's some more down here we need to talk about. When you have 2 or more events, the way you calculate the probability of those events is by multiplying the individual probabilities. We're going to talk about that now. So you roll 2 dice and you want to get 2 4s. What's the probability you'll get a 4 on the first one? There's 1 4 out of a total 6 different numbers you can get. And the second die, there's 1 4 and 6 total. And then again, the way you calculate any 2 events is you multiply them. So 1 times 1 is 1, 6 times 6 is 36. So the probability that you'll roll 2 dice and get both 2 4s is 1 out of 36. You flip a coin twice and get tails both times. So what's the probability you'll get tails the first time? Favorable is 1 out of 2 possible outcomes, and then you do it again, and it has no impact on the second time. It still has 1 tails out of 2 possible, So 1 times 1 is 1, 2 times 2 is 4. So the probability that you'll flip a coin twice and get both tails is 1 out of 4. How about if you flip a coin and then roll a die and you get a heads and you roll a 4? What's the probability that you'll get a heads? That's 1 out of 2. And land on a 4, there's 1, 4, and there's 6 total numbers on your die. So 1 times 1 is 1, 2 times 6 is 12. So the probability that you'll roll a 4 and flip and get a heads is 1 out of 12. All right, now it's marbles, not Jolly Ranchers. You have 5 red marbles, 4 green marbles, 1 yellow marble. You randomly choose a marble, replace it. Okay, it's important. If you replace it, it means those events are independent. It doesn't matter what happened the first time. You go back to the beginning. And you choose a second and get yellow both times. So what's the probability you choose a yellow the first time? There's 1 yellow marble, and it looks like we have a total of 10 marbles. We put that marble back in. So how many yellow marbles do we have? We still have 1, and we still have 10 marbles total. So it looks like the probability that we'll get 2 yellow marbles is 1 out of 100. All right. Then there's something called dependent events, which means it is affected by the previous event. An example they have here is you have 3 blue marbles, 2 red marbles in a bag. What's the probability that you're going to get a blue marble? The probability of blue, there's 3 blue out of 5 total marbles, but then you don't replace that blue marble. And so now there's 2 blue marbles and 4 total marbles. So what's the probability you'll pull a second blue marble? Now there's only 2 marbles, 2 blue, and there's only 4 total. So it's 1/2. So what's the probability that you'll pull 2 blue marbles without replacing it? We said the first time was 3 out of 5. The second time was 1 out of 2. You multiply those together and you get a total of 3 out of 10. Okay. That's called dependent events. It depends on what happens the first time. All right, here's an example I made up. You choose a card at random from a standard deck of cards. Again, you do not replace it. So that they're dependent events. And you choose a second card. What's the probability of first draw a 3 and then draw a 5? So the probability of getting a 3, remember there are 4 3s, there's 4 of every number, out of a total of 52 cards. Okay, this time we're not putting that 3 back. And there's still going to be 4 5s, but now we only have 51 cards in our deck because we didn't replace the last one. So we have 4 times 4 is 16, 52 times 51. That looks like that gives us 2,652. And let's go ahead and reduce that. I'm going to let my calculator do the work for me. And it looks like it's a 4 out of 663 probability. All right, you have 10 green, 8 red, and 6 blue M&Ms. You choose one and you eat it. You don't replace it, obviously, and you choose another. So what's the probability you'll get a red, and the second time you'll get another red? Well, there are 8 red M&Ms in our bag, and it looks like we have a total of, what's that, 14, no, what am I saying, 24? Yeah, it looks like 24 M&Ms. Okay. The second time, you just ate a red M&M. So now we only have 7 red M&Ms, and now we only have 23 M&Ms left. So the probability the first time was 8 out of 24. The second time, it's now 7 out of 23. What's the probability it's going to be red and red in a row? You multiply them together. So we have 7 times 8 is 56. 24 times 23 is 552. And let's see if we can reduce that. 56 over 552 is going to reduce to 7 over 69. Okay. Please try the practice problems. Let me know if you have any questions. Thank you.